In this lesson, we are going to be going over exponential graphs, and this is part 1. In this lesson, we will understand exponential functions, and then we'll learn how to graph exponential functions. So exponential functions come in the form f of x equals a to the power of x. So a is our base, x is our exponent, okay? And for our base, a has to be greater than 0, which is another way of saying a is positive, and a is not equal to 1. So a is positive, can be anything that's positive except for 1. Okay? And here's what the graph looks like depending on what a is equal to. So if a is in between 0 and 1, meaning that a is a fraction, like for instance 1/3 is between 0 and 1, we have a graph that, looking at it from left to right, it starts up high, and as we go to the right, it gets closer and closer to the x-axis. Okay, so for a greater than 1, so something like 2 or 3, this is going to be the general shape, where to the left it's going to start off low, really close to the x-axis, and it's going to grow as the x values get bigger. Okay, so these are just the general forms. So if a is in between 0 and 1, it'll look like this graph on the left, and if a is greater than 1, it'll have the form of the graph on the right. So let's talk about how these graphs come to be. So we're going to graph a few of these. So for instance, let's say we have graph the function f of x is equal to 3 raised to the power of x. So in this case, our a would be equal to 3, so we expect something that looks like this. Okay, so let's plug in some x values and get some corresponding y values, and then draw the graph. So let's say we plug in x's, let me start with 0 actually. X is 0, so this would give us 3 to the 0 power, and anything to the 0 power is 1. Okay, so I'd have an ordered pair of 0, 1 from x equals 0. If we plug in 1, we have 3 to the first power, which is just 3, so we'd have 1, 3. Okay, now I want to plug in x as -1. So if I plug in -1, this is 3 to the negative first power. Remember, to make the exponent positive, we interchange the numerator and the denominator, so this becomes 1 over 3 to the first, which is just 1/3. Okay, so I have a point then at -1, 1/3. So let's graph this. So I have 0, 1, I have 1, 3, and then I have -1, 1/3, and I'm just going to estimate. So this is what the graph would look like. So let's try another one. Graph the function f of x is equal to 1/2 raised to the power of x. So in this case, a is equal to 1/2, so we expect something more so like this. Okay, so let's plug in 0 again. So we have 1/2 raised to the 0 power. Anything to the 0 power is 1. So I have a point at 0, 1. If we plug in 1, I get 1/2 raised to the first power, which is just 1/2. And let's say I plug in -1, where I get 1/2 raised to the negative first power. This becomes 2 over 1 to the positive 1, which is just 2. So I have a point at -1, 2. Oops, and this point was 1, 1/2. Okay, so let's graph it. So we have 0, 1. We have 1, 1/2. And then we have -1, 2. So this is approximately what the graph of f of x equals 1/2 raised to the x looks like. Okay, so now what we're going to do is we're going to take our exponential functions and apply some transformations to them to be able to graph them. So recall when we talked about function transformations that we could have a vertical stretch or shrink, also a reflection across the x-axis. We could have a horizontal or a vertical translation, which moves the graph up and down. We could have a horizontal stretch or shrink, and in that is including a reflection across the y-axis if that value is less than 0. And then we could have a horizontal translation, which moves our graph left to right. Remember, we follow the order of operations, that what's around the x goes first, and then we work our way out. Okay? So example 1, use transformations to graph f of x is equal to negative times 2 raised to the power of x plus 1. Now a in this case is still 2. Okay, so this negative is a transformation. It's not part of the base. So in this case, we would start with f of x is equal to 2 to the power of x. And I am going to graph these all on the same graph to give you an idea of what they look like. But I believe in the homework software, you can plot points, or you plug in the graph that we start with, and then you apply the transformations, and the software helps connect all of that together to make the graph. Okay, so 2 to the x, I'm just going to start these off at At 0, it's 1, and at 1, it would be 2, okay, just like we did at the table. I should have done this in green, hold on. Okay, so this is the graph of 2 to the x, okay, and then what would come next is the negative out in front, and the negative out in front is a reflection across the x-axis. So this is reflect across x. Okay, so what that would look like is in purple, and then the plus 1 is going to move it up 1. Okay, so that's a vertical translation where we're moving it up. So these couple of points that I just drew go up 1. Okay, and the graph looks like the line in blue. Okay, so blue is the final answer. So the green was what we started with. The purple was applying the reflection across the x-axis, and then plus 1 is the last thing we have to do, and that is what the graph looks like. Example 2, use transformations to graph f of x is equal to 3 raised to the power of x minus 2. So what we start with is f of x is equal to 3 to the x. If we plug in x is 0, we would get y is 1, and if we plug in x is 1, we would get y is 3. So I'm going to start with those 2 points. Okay, and then this x minus 2, since the minus is with the x, you can think of it as there's parentheses around this. Oops. Okay, this is a horizontal shift to the right 2 units. Okay, so my 2 points that I drew are going to go to the right 2, and then I'm going to have purple is the final answer. Okay. So we took 3 raised to the x, and then we just shifted it to the right 2 units. Next, use transformations to graph f of x is equal to 2 plus 4 raised to the negative x power. So again, we would start with f of x is equal to 4 raised to the power of x, or 4 to the x. If we plug in 0, we would get y is 1, and if we plug in 1, we would get y is 4. Okay. So this negative x is a reflection across the y-axis. So if we reflect it across y, it's like we fold it along the y-axis and put the image there. So we'd still have a point here, and then we'd have a point at negative 1 comma 4. And then even though this 2 is on the outside, you could rewrite this as 4 raised to the negative x plus 2. This is a vertical shift up 2. Okay, so each of our points is going to move up 2. So we have 1, 2, and then we have 1, 2. And this is what we have. Okay, so something along those lines. So like I said, in the software, it helps you piece all these together, but I also wanted to give you visuals of what's happening here. So again, the graph in blue would be the final answer. Last example, use transformations to graph f of x is equal to 4 minus 3 raised to the negative x power. Again, we start with f of x is equal to 3 to the x. Okay, and you can rewrite this if you want to say negative 3 to the negative x plus 4, where you keep all of the signs. So since there's a negative in front of the 3, that has to be accounted for, and then we add 4. Okay, so 3 to the x, we would have a point at 0, 1, and 1, 2, 3. Okay, and there is a lot going on with this one. So we would start with the negative in front of the x. Again, picture this, anything with the x as being in parentheses, and we do that first. So this negative x is reflect across the y-axis. Okay, so we reflect it across y, and we have something like this. Oops. Okay. Now the negative in front of the 3 is a reflection across the x-axis. Okay, now again, I'm getting these from our function transformation. So that was a previous lesson. If you want to go back and review those, you can. I did show the slide, but that's where I'm getting all of these transformations from. Okay, so then we reflect this across the x-axis. Okay, so we would have a point, instead of a point at 0, 1, we'd have a point at 0, -1, and instead of a point at -1, 3, we would have a point at -1, -3. So something like this. Okay, and then that 4 is going to move the graph up 4. So everything goes up 4. 1, 2, 3, 4. 1, 2, 3, 4. So in this case, the red line would be the graph of f of x is equal to -3 raised to the -x plus 4. Thank you for watching. If you have any questions, feel free to reach out to me.